When solving radical equations, we often have to square each side so that we can remove the radical and get the variable outside of the radical to solve the equation. So we need to have some familiarity with squaring an expression. And I have these three examples listed just to show you what happens. So if we have the square root of 25 quantity squared, well, the square root of 25 simplifies to be 5, and when we square it, we get 25. The square root of 9 squared, square root of 9 is 3, but 3 squared is 9. The square root of 144 all squared, well, the square root of 144 is 12, and 12 squared is 144. Do you notice what's happening? When you square a radical expression, we were just getting what was inside the radical. If the square root expression is defined, the square root of x squared will just give us x. So it's a key thing to understand that squaring will undo the square root. Here's some examples just to enforce that. Again, the square root of 100 squared, I don't really have to think of the square root of 100 as 10 because squaring the square root just gives me what is inside. So I get 100. The square root of 53 all squared, squaring undoes the square root to just give me 53. The square root of x plus 2 squared is just x plus 2. The square root of 3y minus 4 squared is 3y minus 4. So again, we're thinking of the square undoes the square root to just give us what was inside. Now we have 2 on the square root of 9 squared. Well, here we have to remember the properties of exponents. That is to square 2 and also to square the square root of 9. Because we have a product squared, we apply the exponent to each of those factors. 2 squared is 4. The square root of 9 squared is just simply 9. So 4 times 9 is 36. 3 on the square root of x plus 1 squared, in a similar manner, we have to square 3 and square the square root of x plus 1. So 3 squared is 9. The square root of x plus 1 squared is just x plus 1. If you want to multiply that out, 9 times x plus 1 is 9x plus 9. And in the last example, we have the square root of 2 plus the square root of 3 squared. This one differs from the others because we have a sum of radical terms being squared. We don't have a product and we don't have a sum inside a radical. So here we have to apply the square of a binomial, which really means to do the square root of 2 plus the square root of 3 times the square root of 2 plus the square root of 3. And then we distribute or apply the FOIL method. But the square root of 2 times the square root of 2, that's really the square root of 2 squared, or just 2. The square root of 2 times the square root of 3 is going to be the square root of 6. The square root of 3 times the square root of 2 is the square root of 6. So when we multiply radicals, we multiply within the radical expressions. The square root of 3 times the square root of 3 is the square root of 3 squared, which is just 3. Combining like terms, the 2 plus 3 is 5. Square root of 6 plus square root of 6, those are the like terms, so remember we have 1 and 1, so 1 and 1 is 2 on the square root of 6. So that simplifies to just 5 plus 2 square root of 6.